Hello everyone, and welcome to our tutorial class. Today, we're going to talk about one of the most important ideas in all of mathematics. But it's not a big, complicated idea. In fact, it's the smallest idea you can possibly have. We're going to explore the point. Now, I know what you're thinking. It's just a dot. But by the end of this class, you'll see that this tiny dot is the foundation for everything from the shapes in this room to the GPS in your phone. We'll cover three key things today. 1. What exactly is a point? 2. A quick journey through its fascinating history. And most importantly, how we use points to build everything else. So, let's get started. Let's begin with a simple experiment. Everyone, take your sharpest pencil and make the tiniest, smallest dot you can in your notebook. Great! Now, look at that dot. In the real world, that dot has a size, right? You can see it. But in the world of mathematics, we need to be more precise. We imagine that dot getting smaller and smaller and smaller until it has no size at all. That's our first big idea. A true mathematical point has no length, no width, and no height. It is a location, not a thing you can measure. It's the idea of a perfect spot. Can anyone give me an example of a location in this room? Not an object, but a specific spot. Excellent examples. The corner of the table is a great one. In reality, the corner is a little rounded, but in our minds, we can think of the perfect, infinitely sharp corner. That is a point. This leads us to a fancy term, zero-dimensional or 0D. A line is 1D because you can only move back and forth along it. This sheet of paper is 2D because you can move left, right, and up and down. A point is 0D because there is nowhere to move. You're either on the point or you're not. It's the simplest possible object in geometry. So, who figured this out? The story of the point is as old as geometry itself. First, around 300 BCE, the ancient Greeks, a mathematician named Euclid, wrote a book called Elements, which became the geometry Bible for 2,000 years. And his very first definition was this. Let's think about that. Has no part. What does that mean? It means it can't be divided. It's the most fundamental piece. If you try to break it, there's nothing there. It's pure location. Now, fast forward to the 17th century. A French philosopher named René Descartes was lying in bed, some say looking at flies on his ceiling, and he had a brilliant idea. He thought, what if we describe a point not just as a dot, but with numbers? He invented the coordinate plane. Now, every point has an address. This point isn't just a dot, it's 3, 2. This merged algebra and geometry and changed math forever. Today, mathematicians take an even more abstract view. They say, we don't need to define a point. We just need to know the rules for how it behaves. For example, the rule is, through any 2 points, there is exactly one line. This is where it gets exciting. Points are the building blocks of the universe. At least in mathematics. Think of them as the atoms of geometry. What did I just create with these 2 points?
A line.
Exactly. 2 points define a line segment. And with these 3 points, I can build a triangle. Every shape you've ever seen, squares, circles, complex 3D models, and video games, is fundamentally just a collection of points. Real-world example, I'll hold up a map. See the dot that says London? Is that dot the actual city of London?
No.
Of course not. London is huge. That dot is a point that represents the location of London. The lines of latitude and longitude form a giant coordinate grid over our entire planet, giving a unique point for every place on Earth. Your phone's GPS uses this exact principle to find you. All right, let's bring it all together. What have we learned about the Humble Point? Number 1, what is it? It's a location with no size. It's zero-dimensional. Number 2, its history, from Euclid's philosophical definition to Descartes' numerical coordinates. And number 3, its power. It's the fundamental building block used to create every other shape and describe locations in the real world. So the next time you put a dot on a piece of paper, I want you to remember that you're not just making a mark. You are using the most basic, powerful, and fundamental tool in all of mathematics. You are defining a location. You are creating a point. If you have any questions, drop them in the comments below. Thanks for watching. See you in the next class.